All right, we're going to be looking at central limit theorem sample proportion. There's a couple of different variables in here that you need to pay attention to. But again, as long as you're writing down the formulas and following the formulas, then you should be fine. So the first variable is our P. Our P is our proportion, which is our percent written as a decimal. And that's going to be given to us right at the beginning of the problem. Our first question asks us for the mean, and that is P. So it's very simple. You're just putting what P is for the first answer. Your second question is going to ask for the standard deviation, and that is going to be the square root of P times 1 minus P over N, which stands for the number of trials. The last question, we're going to have the P with the little caret on top or the hat. That's your sample proportion. That's going to be given to you in the third question. And then with our P, which is our original proportion, and our standard deviation, which we found in the problem before. All right. So let's give it a try. This is another topic that we do with our Alex calculator because it's nice and simple. So it says empirical research on stock market data for 2 consecutive trading days indicates that 50% of the stocks went up on the first day. So that is our P, but we're going to write it as a decimal. Our mean is 0.50. Yesterday, 400 stocks went up. 400 is going to be our N. Find the mean. Oh, we did that. Find the standard deviation. So standard deviation is going to be the square root of P, which is 0.5, times 1 minus P over N, which is 400. So P, 1 minus P over N. And we get 0.025. And then our last question says, compute an approximation for P, which is the probability that fewer than 51% of the stocks went up. So again, we're looking at our formula. This one says Z is less than, so we're just going to go straight with it. If it said more than, we would have to do our 1 minus. So here our sample proportion is 51%, 0.51, minus our given, our original, which was 0.50, over our standard deviation, which we just got 0.025. Round to 4 decimal places, 6554. So again, once you're using your formulas and you know what the variables stand for, it's not too much work. You just have to make sure that you understand what your variables are standing for. Also, that you're reading things correctly. Let's try one more. All right. Minority representation group accuses a major bank of racial discrimination. Exactly 16% of all applications were from minority members, and exactly 14% of the 2,100 open positions were filled by members of minorities. So 16% is our given mean, 14% is the sample mean, or the sample proportion. So our given is the 16%. So our mean is 0.16. Find our standard deviation. Our standard deviation is going to be the square root of the 16% times 1 minus 16% over the N, which is the 2,100. Oops. And then it says compute an approximation where the probability that there will be 14 or fewer members. Fewer, which is less than. So again, we're going to stick with it exactly the way it is. The 14% minus the 16% over the standard deviation, which made me realize I forgot to write that. I forgot the 8. So the probability that 14 or fewer percent is 0.0062. So this is a good example of how we use statistics to tell us the minority representation group is blaming or is accusing this bank of racial discrimination. If 16% of applications were from minority members, you might say, oh, 14% isn't really that small of a number for people that filled the positions. But really, the chances of so few people filling the positions is, if we move the decimal point, 1, 2, is still 0.6% chance that something like that would happen. A 0.6% chance shows that it's not really likely that only 14% of people would fill that position. So it's a good example that that is probably true, that there was racial discrimination in that case.